So in the last class, we were discussing strings and we looked at a few examples. So this was the last example that we looked at. So let me show it here. So we have a array, small array of size 3, but we are giving a larger string, and then we are trying to print much larger sequence of characters. And what did we see? So when we try to run it, it is printing. So first 3 characters are being stored in the array, and the 4th character is null character, and the remaining characters are all random characters. Okay, so the remaining characters will change. First 4 characters will remain the same, all right, and the remaining characters are changing. They are all random characters. So this is the last example that we saw in the last class. So let's look at the next example. Yeah. What is not assigned to 0? Yeah, so the remaining characters, they're not assigned to 0 because they are some other locations in the RAM where some other processes are running. No, not white space characters. You see, the character array size is 3. So some space is reserved in the RAM only for this array. There will be other cells in the RAM before this array and after this array. We don't know what data is there, but you can try accessing that and print that. So we don't know what data is there that will be printed, but those are some random numbers. Those numbers, if they fall within the range of 0 to 255, the corresponding character will be printed. If it falls outside that range, some garbage will be printed. Question mark characters, it means those the corresponding integer values there, it may be a negative integer or it may be too large integer. So there is no printable character corresponding to that integer. That's why you are getting those question marks. And another thing is, every time you close and run this program, it is not necessary that this array is created exactly in the same location in the RAM. Sometimes it is created in a different location, again some other location, again some other location. So the neighboring cells may have entirely different values. So you will keep getting different values every time. It will have, so the next example will sort of answer your question. Now, there is a slight difference between the previous example and this one. So let's see this. So here, what are we doing? Here we have a character array of size 20, and we are storing a much smaller string. Now, if we iterate over this entire array and print the characters or the ASCII values, what will we get? Yeah, 0. Hello. We are printing the ASCII values of each character. So ASCII values of hello, and then and then 0. That's it. ASCII value of null character, that is 0. So because this array is defined by us and this memory is allocated for this array, whatever are the visible characters, they will take the first few cells, and the remaining cells are initialized to 0 by default. This array is in our control. But in the previous case, array had only 3 bytes. The remaining cells, they have some other content. We don't know. We are just printing them. We are not overriding them. Here we are, the compiler is overriding that data, previous data, whatever was there, that is being overridden with this hello and then zeros. Okay. You see? So ASCII values of hello and then null character, all these are null characters. ASCII value is 0. Okay. So now, no matter how many times you print it, you will get the same thing because this is not arbitrary or optional. It is filled with zeros. That's how it is programmed. But if you access beyond the array limits, then every time you print, you will get different values because array is being created at different locations in the RAM each time. Okay. This will also work in the same way. So either you store hello as a string, you assign hello as a string, or you assign each character separately. Both work in the same way. Even in this case, array size is much larger. You are storing only 5 characters. The remaining characters are all initialized to 0. I mean, characters are initialized to null character. If you print its ASCII value, you will get zeros. If you print the character, you will see nothing because you can't print a null character. Okay, here also we are printing ASCII values. Only the first 5 characters ASCII values are non-zero and the remaining characters are all zeros. Okay, so any remaining space, any buffer space in the array, it is initialized to 0. Okay, all right, now let's try this one. Slightly longer code, but easy to understand. I'll explain it. So first, let me comment this part. So here there is an array of size 20, and we have already assigned a string of size 19 plus a null character. Automatically, a null character will be stored in the 20th position. So this is an array of size 19 because you have digits from 1 to 0, that is 10 digits, and again from 1 to 9, that is 9 digits. So total 19 digits plus a null character, they are stored in this array. Okay. Now we are asking the user to enter a string which is less than 20 characters and storing in the same array. It will override this array. All right. Now, only one thing which we are checking for is if there is an @ symbol in the string. Say you found that @ symbol. Suppose you are giving an email ID. If there is an @ symbol, you say you found @ symbol. Otherwise, you just print the character. You just print the string and exit. Okay. So suppose I say abc@gmail.com. So this is the string I entered. So it printed that string, and then it said, okay, there is an @ symbol in the input string. Suppose I just type ABC, no @ symbol. It will just print that string. It didn't find any @ symbol. It just printed ABC. It didn't find any @ symbol. Fine. But now the point is, why is it stopping at abc@gmail.com or just ABC, not all the 20 characters? It is because in the for loop, we gave the condition to stop at null character. That is the terminating condition. Okay. Now, in the next for loop, what we will do? Sorry. So in the next for loop, what we will do? We will not stop at the null character. We will just go up to the last index in the array. We will print all the 20 characters. Fine. Now let's see what it will print. So any guesses? Suppose I just give ABC as the user string. This is the string stored in the original array, and then I give ABC as input. Then I can print in 2 different ways. Suppose I say stop at null character, then it will print ABC. Because when you input ABC, it will store ABC along with the null character at the end. Okay. Now I say don't stop at null character, print all the 20 characters. So any guesses what it will print now? ABC 4, 5, 6, 7, 8. That is one way. So basically only the first 3 characters are being overridden. The remaining characters remain as they are. Okay. So let's see. First for loop, you stopped at null character. It printed ABC. Second for loop, you printed all the 20 characters. But here it is not printing 4. It is printing from 5. Why? Null character. So it is storing 4 characters. Visible characters are 3, but it is appending null character to that and overriding the first 4 cells, not just 3 cells. So 1, 2, 3, 4 are overridden with ABC null character, and remaining characters remain as they are. Okay. Now the last for loop. Here we are going beyond the array size. Array size is only 20, but we are going up to 30. Now what will be the output? If I input ABC, what will be the output? ABC and then 5, 6, 7, 8 and so on, that entire string, and then random values. Okay, because outside the array, we don't know what values are there. Any values can be printed. Okay, so that's what will be printed. See, here it stopped at last digit of the array, last character of the array, but here we went beyond the array. So these are some random values and they don't have corresponding characters because these numbers fall outside ASCII range. So they are unprintable characters. That's why you see question marks. Okay. So if you limit yourself to the array size, all the characters in the array are printed. But if you go beyond the array size, random values are printed. Now within the array size, you have two options. Either you stop at null character or you give the actual index up to where you want to go. Okay. So null character is not a special character when you are using index. When you are using index to traverse the array, null character is like any other character. It will not say, okay, there is a null character in between, you can't go beyond this. It will not say that. There are different characters, 1, 2, 3, 4, 5, 6. Similarly, there is a null character. After that, there are some other characters. You print each character. Only when you tell me to stop, I'll stop. But null character is useful when you are using percentages. Okay, so either you just use percentages, it will stop at null character, or you explicitly say stop at null character if you are using a loop. Okay, start from 0 and stop when you see the null character. Otherwise, you need not stop there. In principle, you need not stop there. You can go up to even 1 million. Nothing stops you. Null character is like any character. It becomes special when you use percentages or when you use it as a delimiter in your loop. Okay, so the same thing. So this for loop is starting from 0, index is starting from 0 and stopping at null character. Instead of this for loop, we can just give print. Oh, sorry, this is already doing that, right? You are saying print percentages, use a string. It is printing only ABC. It is not printing ABC 5, 6, 7, 8. Why? Because when you use percentages, it stops at null character. That's all. So when you read a string from the user, it will automatically insert null character at the end. That's all. Okay. Any doubts? Maybe you need to practice for you to, there may be some confusion in different scenarios. Only through practice, those confusions will be resolved. Okay. All right. And next thing we discussed yesterday, what if I want to scan a string with spaces in between? Okay, so this we discussed yesterday. Suppose if I say hello world, when I say scanf percentages, the input string. So what will be stored? Only hello. It will take only hello. It will not take hello world, entire world, because they're separated by space. All right. But many times, suppose if you are, say you are writing a quiz on Euclid and there is a subjective answer, or forget, you're typing some message on WhatsApp. This message will have spaces, punctuation marks, full stops, all kinds of things. It can have tabs or whatever. Now, until you press the send button, or if you are typing in computer, until you press the enter button, the message will not be sent. And even when you press the enter button, the entire message will be sent across, not only the first word, right? So what if I want to read the entire string until the user presses enter, right? Including spaces, tabs, and all punctuation marks. So how to do that? I want to read the entire string, right? So there are commands for that. There are basically three. I mean, there are a couple more also, but these three are sufficient. But within these three, the first one is strongly recommended against using. You should not use the first one. It will work, but it is dangerous to use it because it does not put any limit on the input size. Even if you give 1 million characters, it will try to read until you press the enter button. Okay, so these kind of functions are the ones which are actually used in hacking. Because say when the coder, you see, I build suppose a web page, and my web page has different forms and they have different purposes. Maybe I'm asking you for your name, address, something like that, and I assume that the user will enter only these details, right? But if a hacker understands that you're not putting any limit on your input, then after putting this information, they can inject a code which will run on your server and sort of harm it. Okay, so that's how hacking is done. These kind of minor mistakes lead to security issues. So these are the kinds of bug fixes. When people say, okay, we fixed a bug, this gets input will be replaced with the other two commands, fgets or scanf later. Okay, it will work, but if you use it normally, there is no problem. But if someone wants to misuse it, then that scope should not be provided by the programmer, right? So that's why these kind of functions are dangerous. Gets is dangerous because it does not put any limit on the string length, whereas the other two functions, they put a limit. Fgets does, scanf also does, sort of, in the sense until you press a new line, it will scan, but gets one can sort of in gets one can even skip new lines and insert something else. Okay, so let's not worry about that. All that I want you to understand is there is a command called gets, and you will find it online if you look for it, but you should understand that you should not use it. Okay, use the other two commands. So now let's use these two commands. So fgets is a generalized version of gets. Gets basically assumes that you are giving input only through standard input, that is through the terminal. Fgets allows you to get the input either from standard input or from a file. Like suppose I want to read a file. I want the program to open some file on my hard disk and read it. I won't give the input. Suppose I have a file of 100 students and their marks. I want my program to read all the students' names and the marks and then sort them and then write it in a different file, right? So I need not read that file and then enter them in terminal and then this program scans it. No, already I have that information. Again, why should I type it? So I want the program to open the file, read the information and sort it and store in a different file. Or you see, I can actually show it to you. Suppose I print some numbers, 93, 23, 98, 7, 46 to 34, something like this. Okay. Now I want to sort these numbers. All right. So in Linux, there is a command called sort test.txt, and I print. These are sorted alphabetically, not numerically. Okay, alphabetically. These are assumed as strings, not necessarily numbers. But we can sort them numerically also, like in Excel. We can do that. This is just an example. Now, what is this sort doing? It is accessing the file. It is opening the file. It is reading word by word, and it is storing them in its memory, and then it is sorting them, and then it is printing it onto the screen. Suppose I want to send this output not to the screen, but to another file. All I need to do is out.txt. So now there is a new file out.txt that is created. This will have the sorted data. You see, this entire thing can be done through program. So now I did not give the input to the sort function. Sort function is also some C code. Okay, that is expecting you to give some input. Now either you give that input through terminal or you give that input through a file. Okay, so there are different ways in which input can be given. Fgets takes the input either through terminal or through a file. If you are giving the input through terminal, then you write std in. If you are giving the input through a file, then you give that file pointer. File pointers we may not have time to discuss, but files can also be read and written through programs. Okay. All right. So this is the format. Input means input array name, where the user input should be stored, and then maximum length of the input string, and then where is the input coming from? Is it coming from terminal or is it coming from a file? If it is file, give the file name. It's actually file pointer, but you understand it, file name for simplicity. If I'm reading it directly from the terminal, write std in. If it is a file, write the file name. Okay, so let's use that. So here, instead of scanf, so I'll use this later. I will use fgets. Input array is A. That is where the input string should be stored. And then maximum length of the input string should be 20. And then where am I getting the input from? Is it from a file or standard input? Standard input. So just write std in. Okay. Now, when I print %s A, even if the user input has spaces in it, it will take that. Now I say hello world. It took hello world. It didn't stop at hello. All right. So this is one way. Another way is we will use scanf. So in scanf, this thing inside is called a regular expression. Any of you heard of regular expressions? No. Okay. So regular expressions are they are used to sort of match more than one word at a time. You see, when you search in Word or something like that, you have to type the exact word. But sometimes you see this checkbox, make the search case insensitive. That is, if I'm looking for a word, whether there are some capital letters in it, small letters in it, search for all those words. In that case, what is happening? It is converting it into a regular expression and matching. Say, suppose I want to search for all the words starting with or ending with ed. Doesn't matter. Some words ending with ed. Now, how do I say that? I need to imagine all the possible words ending with ed, and I need to list all of them. Okay, search for this word like red. Search for this word like mist. Search for this word like anything, kicked. Whatever it is, you need to list each word and then search for each word. That is too much. I want the computer to just search for all the words ending with ed. How do I say that? Right? So for that, you use a regular expression. You will learn about them. In Python also, you can use regular expressions. Even here we are using. Particularly in scripting languages like Perl, etc. Also, you can use it. Many scripting languages provide this. This you will also learn a bit more in theory of computation later. Okay. So basically here what we are saying is, I want you to read all the characters until you get a new line character, but don't read that new line character. Okay. So except new line character, you read all the characters. Until you get a new line character, keep reading the characters. That's what it is saying. Okay. So in case you find this expression hard to remember, you just use fgets. All right. So scanf, percentage, square brackets, caret, \n, close the square brackets, again percentage $C. All right. So percentage $C means you read all characters until you get the new line character, but don't include the new line character. Okay. See, it read the entire string, including space, but it didn't include the new line character. In the previous case, fgets, it included the new line character, right? Here, it did not include the new line character. That's the only difference. Fine. Now in fgets thing, this is fgets, right? So suppose if I give a larger string, what will happen? I put a limit on the string, so it will truncate it up to that point. I said only 20 characters, so it will probably read 19 visible characters and append null character at the end. That's all. All right. But in scanf, I did not put a limit on the string. So now let's compile the sixth one. This is scanf1. It took the entire thing, but the problem is the array size is only 20. Right? So although scanf is reading the entire string beyond 20, it is waiting for the new line character. It is trying to store that in the array. It is overflowing. The array's memory is not sufficient. This is what is happening when you just even without giving any spaces. If you give a very large string, same thing will happen, right? It's not about spaces or no spaces. It's about giving a much larger string. Okay. So there are two things. If you are giving a larger string in the code itself during initialization itself, then this error will not occur. It will just truncate it. Like if you remember a of 3 equal to hello, it just truncated. It did not give this error, stack smashing detected. But if you are scanning that string from the user, which is much larger than the array size, then this error will come. Okay. All right. And so there are some library functions to deal with characters in C, inbuilt library functions. Some of these you sort of implemented on your own, like, yeah. In this case, it didn't truncate. It just said stack smashing detected. In this case, it truncated. In fgets, it truncated, but in scanf, it didn't truncate. You see, the point is you are giving it through standard input. So first it is going into the buffer and then it is stored in the array. So here it is being read into the buffer. So what is being, so scanf works slightly differently, fgets works slightly differently. Fgets truncates and then stores it in the character array. Scanf is taking everything into the buffer and then without truncating, it's trying to store it in the character array. That's why here stack smashing is detected. Okay, so they work slightly differently. That's why there are two different functions. All right. Sorry, it is not getting stored at all. It is stored in buffer for the time being. But when it is trying to store that entire thing within the array, it is getting an error. So you are ending with error. It is not getting stored anywhere. Yeah. Yeah. So there are some functions to handle characters in C. Some of these you implement on your own. Say, for instance, you wrote a program given an input character, say whether it's an alphabet or a number, or whether it's a lowercase character or an uppercase character. So what did you do? You either use their ASCII values, like if the character's ASCII value is greater than 95 and less than 107 or something like that, 126 or something like that, then it is a lowercase one, or you directly use the characters. If the character is greater than or equal to small a and less than or equal to small z, then it is a lowercase character, right? So instead of doing all this, you can use these inbuilt functions. These inbuilt functions are implemented in the same way in the backend, but knowing these functions will make your task much easier. So is lower will check whether a character is of a lowercase or not. Is upper will check whether a character is of uppercase or not. Let's just try out a couple of them. Suppose I have some character, I scan it from the user. Now what I will do, if so is lower, is upper, they are Boolean functions. They return true or false. If the character is of lowercase, is lower will return true. Otherwise, it will return false. Similarly, if the character is of uppercase, is upper will return true. Otherwise, it will return false. Right? So if is lower, ch. Okay, to run these functions, you have to include a library called ctype.h. All right. Print %c is of lowercase. Okay. So I say small h, it says h is of lowercase. If I give a capital H, it will not do anything because I didn't give the else condition. Okay. Similarly, is upper and is an alphabet or not. So is digit will see whether it falls between 0 to 9. Is alpha will see now whether it is an uppercase character or a lowercase character, it doesn't matter. It will say it's an alphabet. Okay. Is all num will say whether it is a character or a digit, it will return true. Otherwise, it will return false. Punctuation, it will return true if it's a punctuation mark, else it will return false. The space, it will return true if it is a space, else it will return false. The last two functions, they are not Boolean functions. They return a character itself, right? Suppose I give a lowercase character, I want to convert it to uppercase. Then I will use to upper. Similarly, I want to convert uppercase to lowercase. Then I will use to lower. So it's not about being true or false. It's about taking an input and modifying it and returning it. Okay. So here what we will do, if character is a lowercase character, we will convert it to uppercase and print to upper ch. Okay. Small h, it will print capital H. If it is capital H, it will not even enter that condition. You can try applying that function on capital letters also, it will just return the same capital letter. Okay. So basically, you can store it. Let me copy this. So this thing you can do like this, or another way is you have some other character ch2, to convert ch to uppercase and store it in ch2 and just print ch2. Okay, both are same. Okay, so these are some functions, inbuilt functions, which you can use to make your job easier. All right. Yeah, strings, that's the next slide. So we have some functions for strings. Okay, but in strings, I don't think there is any function which converts entire string to uppercase. I need to check. You just check it, the list of functions here. But even if such a function is not there, you just run a loop. Run to upward for each character in the string. Okay. Yeah. So these are some string functions. We already saw string copy, right? Now other functions are again easy to understand. String n copy means instead of copying the entire string from one string to another, copy only the first n characters from one string to another. Okay. Similarly, string cat means to concatenate two strings. Suppose I have one string has ABC, another string has DEF. I want to concatenate them into a larger string. I will get ABC, DEF. Okay. Similarly, say I want to concatenate only first n characters of one string to another. So in DEF, I want to concatenate only the first two characters. So I will just get ABCDE, not the entire string. I don't want to concatenate entire string. In that case, use string ncat. And string cat, it will allow you to check for a particular character in a particular string. Like in the previous example, if you remember, we were checking for @ symbol in the input string. So there, what were we doing? We were checking each character. If user string I is equal to @ then print you found @ symbol, right? So you are checking character by character. Instead of that, you use this function, input the character you want to check for, input the string you want to check for. This function will return true if this character is inside this string. Otherwise, it will return false. So you need not run the loop through the string character by character. And then string length. It will input a string, it will tell you the length of the string. All right. String compare. This is a very useful one and a very important one, and also sometimes confusing. Confusing in the sense, you see, like we saw earlier, assignment operators which work on primitive data types don't work in the same way on derived data types. Like I said, if you want to assign an entire list to an array name, you can't give it like a equal to this list of numbers. If you're separating initialization and declaration, you can't do it. If you want to do it in declaration line itself. But later you can't do it. You have to give element by element. Okay. But for string, what you can do, you can use string copy. If you are doing initialization later. If you remember this slide. Yeah, you see here declaration is separate, initialization is separate. This will not work. But declaration is separate, initialization is separate. This will work. Instead of using a equal to hello, you copy hello into a using string copy function. This will work. So assignment operator will not work on arrays. You can't assign an entire array to an array name. Similarly, comparison. You want to compare to, normally if you want to compare two variables x and y, what will you do if x double equal to y? It is true, else it is false. But in arrays, you can't do that. I want to compare two arrays, A and B. You can't say if A double equal to B, it will not work. It will not work semantically, but it will not give you an error because it is not a syntactic error. It means something, but it does not mean what you meant to. It means something different. It means you're trying to compare the pointers, the addresses of these two variables. You will understand that when we get to pointers. So the computer will think you are comparing their addresses, not their values. So you should be careful when you use double equal to or equal to with arrays. Okay. So you cannot use this double equal to compare two strings. Okay. Is string 1 equal to string 2? You should not use this. If you really want to compare their values, the strings, then you should use string compare function. Okay. So you should look up these things. Links are provided. Look up, and you may need to use these to solve your lab problems. You can solve them even without using this, but it's a bit more laborious. Using them will make your job a bit easier. Okay, so you need to spend some time understand them. All right. Yeah.
Used to return the number of characters scanned. Using fgets and scanf, that we did just now.
Scanf does not return number of characters. Scanf will return number of values it scanned successfully. Okay. Yes. So you can do that. Fgets, I don't think will return a value. See, sometimes it's difficult even for us to remember every command's complete definition. So in that case, like I said, if you are using Linux, just use man function. So fgets, okay. Fgets also returns an integer. So what is that integer? Fgets reads the next character from stream and returns it as an unsigned char cast to an int or end of file on end of file or error. Okay, so sorry, it's fgets C, not fgets. Yeah, fgets reads in at most one less than size characters from stream and stores them into the buffer pointed to base. Reading stops after an end of file or new line. If a new line is read, it's stored into the buffer. A terminating null byte is stored. Okay. What about the return one? What does it return? Return value. fgets returns S on success and null on error, or when end of file occurs while no characters have been read. So it does not return the number of characters you read. Scanf will return. Scanf also will not return number of characters you read. Scanf will return number of values you read successfully. That's the difference between scanf and printf. Suppose in scanf I am reading 2 integers. Each of these integers may have any number of digits, but it will return only 2. Whereas printf, if you are printing 2 integers with a space in between, it will return the total number of digits plus space. It will not return 2. That's the difference between printf and scanf. Okay. So you just look up the man pages. These are manual pages, or even look up online fgets and scanf. What are the return types? This you will understand. It will be easier for you to read these man pages when you understand functions. So what is the input of a function? What is the output of a function? How to understand that? Then it will be easy for you to understand the man pages. Okay. Yeah. So you look up these things. You need to spend some time on your own to understand these things. I will not spend time on that. Let's quickly look at some examples of 2D arrays now. So 2D arrays is like, a matrix is what? It's a 2D array. Matrix is nothing but some rows and columns. And if you remember, like the patterns which we printed earlier using for loops or whatever, those are like matrices. Similar thing occurs here also. So if I have 3 rows and 5 columns, then I need to run I from 0 to 2 or 1 to 3. In this case, 0 to 2 because we are dealing with arrays. In that case, we are just directly using loops. We didn't deal with any arrays. We are just printing them. So there you can go from 1 to 3, 0 to 2, or 10 to 13, anything you can do. But here you are using arrays. So the index of rows goes from 0 to 2 if you have 3 rows. And if you have 5 columns, J goes from 0 to 4. Okay. So in a matrix, what is it? If it has 3 rows and 5 columns, it is a 3 by 5 matrix. Similarly, a 2D array is nothing but a matrix. If your 2D array has 3 rows and 5 columns, you write it like this: int a of 3 by 5 rows and columns. Okay. So this is an example of a 2D array. It's a 2 by 3 array, 2 rows and 3 columns. So this is the first row and this is the second row. In each row, there are 3 values. For more readability, you can even write them like this. You see, C is not like Python. You can split it, you can write it in the next line, you can combine all your code into one line. Like the codes which you are seeing, even if it is a 1000-line code, you need not indent it. You remove all the new lines, remove all the spaces, combine it into one line. Even then it will work. It doesn't matter for C. Only thing is, for your readability, you are separating it. For your readability, you are indenting it. Okay. So this is the first row. This is the second row. All right. Now, suppose I want to access, say this element. What will be its index? 0, 1. It is in the 0th row. You see, it's row 0 and this is row 1. Similarly, within 0th row, this is index 0, index 1, index 2. So this element, if you want to access, you have to type numvals 0, 1. Okay, that will give you this 44. What about this number? What will be its index? 1, 2. First row, second element. First row in the sense, index 1, row, index to column. Okay. All right. Now let's try one small example. We'll not, I mean, integers, it's easy to understand. Imagine we have a list of books. Okay. Book names, book titles. And I want to store these book titles. Each book title is a string. I want to store a list of such book titles. So I need an array of character arrays. So it will be a 2D array, right? Suppose I have, say, 3 books and each title is max 20 characters. All right. Now I want to, one is I can scan the book title from the user. Another is I can give the book name in the code itself. Right now, imagine I know the 3 book names. I will give them in the code itself. So how do I give values to the string array or character array? We just saw. Here we are, one way is you do it in the initialization declaration step itself, you initialize, but I'm not doing that. I'm separating declaration and initialization. Then what to do? One by one, but one by one, what should I do? Sorry? Book 1, suppose book 0. Its title is, say, Harry Potter. How do I say, what command should I type here to say book 0 title is Harry Potter? You store Harry Potter in book 0. How do I do that? That's all. String copy. String copy books 0, comma, Harry Potter. You should not write book 0 equal to Harry Potter. That will not work. Okay. Books 0 is a string array, a character array. It's a string. So deal with each of these arrays. Books 0, books 1, books 2, like any normal character array. Okay. Similarly, suppose book 1 title is Sherlock Holmes. Same thing. Book 2 title is say World War II. Okay. That's it. So you're storing this entire string in this. Fine. Now let's try to print them. I want to print book 0 title, book 2 title, book 1 title, book 2 title. All right. All I need to do is %s new line. Here, what should I write? Book 0 title means yeah, that's all. Book 0. Because you see, if you have a character array, if you want to print that entire array, what do you do? %s array name. In this case, first row array name is book 0. That's it. Second row name is books 1. So that is the name. Treat it as a name of that row. That is the array name. So the way you deal with any array, treat these also in the same way. Only thing is the name is given by the index, the original name and the index, row number. Okay. All right. So let's see. We need to include string.h. So to use these commands, string copy or whatever string commands, you need to include string.h. For character commands, you should include ctype.h. Okay. That's it. All the 3 names are printed. Now suppose if I want to access, say, say 7th character in the 3rd book. All right. I want to print that. What should I type? Yes, books 2-6, right? Yeah. Printf, what should I write here? %. See, it's a character, it's not a string. Books 0 is a string. Books 1 is a string, but books 0-2 is a character. Books 1-5 is a character, right? So it might be a little confusing, but if you remember the basics, if you remember the fundamentals, that you are dealing with arrays, string is nothing but a character array, and it is a 2D array where each row in this 2D array is itself an array, and each array is itself a series of characters. So the way you deal with normal arrays, same thing you do here also with 2D arrays. That's all. So percentage C, new line, books 2, 6. So what will it print? Yeah. What should it print? What is the 7th character in the 3rd book? W. Right? So it should print W. That's it. You see, it printed W. Okay. So, particularly when you're dealing with textual data, say, imagine you have a dictionary of words or a list of words. You are asked to sort them in dictionary order. That is alphabetical order. Then how do? You need to use 2D arrays. So this is a dictionary, small dictionary with 3 words. Imagine you have a dictionary with 1,000,000 words or a data set with 1,000,000 words. You're asked to sort them. You need to sort based on alphabetical order. But to do even that, first you should learn how to sort a unidimensional array. This is a 2D array. First, understand how to sort basic integers. Then you see how you can apply it to sort a character array. And then you see how you can translate it to sort a 2D array, a 2D character array. Right? So this might be a bit confusing. The more you practice, the more clear it will be. All right. Okay. So we'll stop here. But before that, before we close the session, as you would have got a mail that HackerRank winner will be given the prize now. So we have Manoj and Vinil with us. So they actually began the programming club last year. It began last year. Officially, they began the programming club, and they were the first 2 presidents, Manoj for 6 months and then Vinil for 6 months. So please, they would hand over the prize. And I want them to speak a few words about the journey of the club and so on.